In this video, we'll be talking about how to do transformations with logarithmic functions. So as you start this video, you should feel really comfortable graphing a parent function of any log base. So log base 2 of x, log base 3 of x. If not, you should go back to another video or to another lesson and make sure that you understand that concept before trying to watch and understand this video. So what we're going to do is we are going to look at a general form of a log equation with as many transformations as we could have, and we are going to talk about what each part of the equation does to the graph. So first, if we have an a, or just the a, b, h, and k are all just going to be any number that you want them to be. So if you have an a or a number in front of your log, that's going to vertically stretch or compress your graph. Whoops. So this is a vertical stretch or compress. And basically what that means is that you, like say you had a 2 in front of your graph, it just means that it's going to stretch your graph out so it's twice as tall as it was before. The next piece that you're going to run into is the base, or the b of your logarithm. And that base is going to tell you what the parent function is. So if it's a log, if there's a 2 there, then your parent function is log base 2 of x. If there's a 5 there, your parent function is log base 5 of x. The next thing you're going to see is your x value. Now, if your x value is negative, that means it's going to reflect the graph. If that x is negative, you're going to reflect it over the y-axis. So that means you're going to flip it left and right. I'll write that down there. The next thing you're going to see is an h value. And this h value is going to tell you two things. First, it's going to tell you if you have any horizontal shifts. So that's like a shift left or right. And it's also going to tell you what your vertical asymptote is. So remember that every logarithm function is going to have a vertical asymptote, and that vertical asymptote is going to change based on whether or not you shift your graph left or right. So if you shift your graph to the left 3, your vertical asymptote is also going to shift to the left 3. And the last thing you can do is you can add or subtract a number at the end, and that's going to shift your graph up and down. So now that we've reviewed all of those transformations, let's go ahead and look at some steps for how to graph transformations, graphing transformations of logarithms specifically. So the first thing that I would do is look at the equation and identify the parent function and then list the transformations that are happening. Then I would graph at least 3 points in the parent function. And you want to either graph them or put them in a table, or maybe both. Then you're going to sketch the vertical asymptote. So your vertical asymptote is going to act as kind of like a reference point as you start drawing your graph. So figure out what the vertical asymptote is by looking at the horizontal shift, and then draw on a dotted line where your vertical asymptote is going to be. Then you're going to start doing the transformations. So if you have any sort of reflections, then if you're reflecting over the x-axis, you're going to change your y values to be negative, and if you're reflecting over the y-axis, you're going to make your x values negative. As I'm reading this, I'm remembering that we forgot to talk about where in the equation we would see a reflection over the x-axis. So let's jump back really fast to this top part. So this a value at the beginning, in addition to indicating if there's a vertical stretch or compress, if that a is negative, it's going to reflect over the x-axis. Okay. So after you've taken care of your reflections, then you're going to do your stretching or compressing. So if you have an a value, then you're going to multiply your y values by a. Then you're going to do your shifts. So if you're shifting left or right, you're going to change your x values. If you're shifting up or down, you're going to change your y values. And then the last thing that I would do is just, if you've drawn your parent function and a transformed function, make sure it's clear which one is your final graph. Okay, so maybe put a star next to it or highlight it or something. And then again, another tip is just to make sure you're keeping track of that vertical asymptote. So let's go ahead and look at one example I've already worked out for you, and then we'll do some examples on our own. So say I want to graph log base 2 of negative x minus 2. So the first thing that I'm going to do is I'm going to identify the parent function. So y equals log base 2 of x. I'm going to use that parent function to create this parent function graph. Okay, and that goes back to a previous lesson in a previous video. Then I'm going to look at my equation again and figure out, okay, what transformations are happening to my parent function? So since I have a negative next to my x, that means I'm reflecting over the y-axis. And then since I'm subtracting 2 at the ends, it means I'm shifting the graph down 2. So what I'm going to do is I'm going to take my parent function table, and I'm going to first handle my reflections. So I'm going to change all my x's to negative, and that's going to make it reflect over the x-axis. So you'll see my whole x value column stayed with the same numbers, but now they're all negative. And then to take care of the shift down 2, I'm subtracting 2 from each y value. And that's where I'm getting my new y value column. Okay. Since I didn't shift either way, left or right, my vertical asymptote is still going to be x equals 0, which means that my domain hasn't changed and my range hasn't changed. So here's actually a fun fact. Your range is never going to change for these logarithms. Okay. So your range is always going to be from negative infinity to infinity. Then you'll see the graph that I have graphed here. I made a computer program graph it for me. But you'll see on the right side in a dotted line, you'll see the parent function of log base 2 of x. And then on the left side, you'll see that same graph, but it's reflected over the y-axis. So it's kind of flipped over left to right. And then it's shifted down 2. So the whole graph is just shifted down 2. So let's go ahead and look at some more examples of these to make sure that we are feeling okay about them. So first thing that I want to do is I want to identify the parent function in this equation. So I have negative log base 3 of x plus 3. So my parent function is log base 3 of x. So I'm just going to go ahead and take care of all my parent function stuff right now. I am going to create a parent function table and then sketch a really rough graph of what that's going to look like over on the right side. So I have 3 rows in my parent function table, so I'm going to choose 3 very specific points. I'm going to choose a fraction, 1, and then a whole number. And I would always recommend starting with this setup as in your original parent function. Now I need to take care of my transformations. So I'm going to first list my transformations. So the negative in front of my graph means that I'm going to reflect over the x-axis. So that means I'm going to flip the graph up and down. And then the plus 3 means that I'm shifting my graph left and right. And remember, the left and right transformations are kind of opposite what you would think. So if you're adding 3, you're actually going to move to the left 3. Okay, so let's go ahead and look at how those transformations are going to affect the values of my parent function. So if I'm reflecting over the x-axis, that means that I'm basically flipping my graph upside down. So I'm going to change all of my y values to the opposite sign. So instead of having negative 1, I'm going to have a positive 1. The 0 will stay the same, and then I'm going to have a negative 1. Then if I'm shifting to the left 3, it means that I'm making all my x values 3 smaller. So I am going to subtract 3 from all my x values. It might help you to grab a calculator and just do 1/3 minus 3 to get that decimal. So when you do that, you'll get about negative 2.7. 1 minus 3 is negative 2, and then 3 minus 3 is 0. So that takes care of my shift to the left. So let's go ahead and fill in my vertical asymptote and my domain and my range. So my vertical asymptote is going to be based on my horizontal shift. So since I shifted to the left 3, that vertical asymptote is also going to shift to the left 3. So originally, my vertical asymptote would be at x equals 0. If I move it left 3, it's going to be at x equals negative 3. It also means that my domain is now going to start at negative 3 and then go to infinity. And again, my range is always the same, negative infinity to infinity. All right, So now we need to kind of tackle the graph over here on the right. So you have two options. One, you can go ahead and graph the parent function and the transformed function, or you can just jump right into the transformed function. I am going to start by graphing the parent function. So I'm going to do that in black. I'm just going to graph log base 3 of x. So I have 1/3, -1, 1, 0, and 3, 1. So this black graph is my parent function. So it's not my answer, it's just a stepping stone to get to the right answer. Now I'm going to go ahead and draw in my transformed graph. So the first thing I want to do is I want to draw in my vertical asymptote, because that's going to be a really good reference point for me. So there's my vertical asymptote at -3. Then I'm going to plot these points. I have -2.7, 1, -2, 0, and then 0, -1. Okay. And now I need to connect those 3 blue points to sketch the graph of negative log base 3 of x plus 3. One thing you want to remember is that you always have to be getting continually close to your vertical asymptote. So I'm going to be kind of going up there, and then I'm going to come down as I go to the right. So that blue graph is what your final finished product graph is going to look like. All right, let's go ahead and do a couple other examples. I'm going to zoom on this one so we can hopefully just see that one example. So we're doing 2 log base 5 of x minus 3. So my first step is to identify my parent function, so log base 5 of x, and then I'm going to use that to create my parent table. And I'm actually going to go ahead and just graph my parent function right now while I'm kind of thinking about it. So this black graph is going to be my parent function. One reason that it's nice to have your parent function graphed is that it's good at the end to be able to compare your parent function to your transformed function and make sure that they do actually match. So your transformations is that you have a vertical stretch of 2 because there's a 2 in front of the function. So vertical stretch of 2. And since you're subtracting 3 from the x, that's going to move your graph to the right 3. So let's go ahead and talk about what that does to our points in our tables. So if I'm stretching the graph vertically by 2, that means I'm basically like holding the top and the bottom of the graph and I'm just stretching it out. So my x values aren't going to change. My y values are going to get twice as big. So I'm going to multiply all my y values by 2. Then if I'm moving to the right 3, that means that I'm going to take all my x values and I'm going to add 3 to them. They're going to get 3 bigger. So I'm going to go ahead and add 3 to each of these. And I am going to change my 1/5 to a decimal just because it's easier for me to graph with decimals than fractions, but you're welcome to stay with fractions if you prefer that. Okay, so I just went ahead and added 3 to each of these. I'm going to go ahead and put the +3 next to each of these in my table so that you know that's what I did. And then I multiplied the y values by 2. So the blue that I'm writing in is telling me what I'm doing to those y values to get my new transformed function. All right, so my vertical asymptote, that is dependent on my horizontal shift. So since I shifted to the right 3, it means my vertical asymptote is going to end up at x equals 3. And let's just go ahead and draw that in right now. I'm going to draw it in red. You're welcome to draw it with just your pencil. So that means that your domain is going to start at 3 and then go to infinity. And your range is still going to be -infinity to infinity. Now, if it's easier for you, you can totally fill in the domain and the range after you've finished graphing the function over here on the right. Okay, I'm going to go ahead and graph the points from my transformed function table. So I have a point at 3.2, -2, 4, 0, and then 8, 2. I'm going to go ahead and connect those dots and mimic the shape of the graph that I know it's going to be. Okay. So I like to see the blue and the black graph next to each other to compare them. Because if I start with the black graph and think about transforming it to get to the blue graph, I should shift it to the right 3, which it does look like the blue one is shifted to the right 3. And the blue one needs to be stretched out by a factor of 2, which it does look like it's steeper and kind of stretched out more. So that blue graph does reflect or is representative of the transformations that it should be. Okay, let's do one more example with these. So first I'm going to identify the parent function, which is log base 4 of x. In fact, I'm going to pause right here. I would recommend hitting pause in the video and trying to work through this problem by yourself. I will work through it step by step, but it might be useful for you to practice some on your own. But okay, let me go back and finish this. So parent function is log base 4 of x. So my x values are going to be 1/4, 1, and 4. Then my y values are -1, 0, and 1. Sorry, the bell just rang at my school. I'm not sure if you guys could hear that through the video or not. But the transformation, since I have this 2 in front of my log, it means I'm going to be doing a vertical stretch of 2, or by 2. And then the -1 at the end means I'm going to be shifting the graph down 1. All right, so let's think about what these two transformations are going to do to my parent function. So I know that the vertical stretch, that's going to affect my y values. I'm going to make my y values taller or shorter. Then the shift down 1 is also going to affect my y values. It's going to pick up all the y values and just make them 1 smaller. So as I think about changing my table, I need to multiply my y values by 2 and I need to subtract 1. And I need to go in that order. So I need to multiply by 2 and then I'm going to subtract 1. So multiply by 2, subtract 1, multiply by 2, subtract 1. So my x values are going to stay exactly the same. So I'm just going to go ahead and copy those over. And then I'm going to perform these transformations. So -1 times 2 is -2, -1 is -3. 0 times 2 is 0, -1 is -1. And then 1 times 2 is 2, -1 is 1. So we have that table made. Let's figure out what my vertical asymptote is. My vertical asymptote is dependent on the horizontal shift, so a shift left or right. Since I didn't shift left or right, my horizontal asymptote is going to stay at x equals 0. So let me go ahead and just draw that in. Okay. Now in this last graph, I'm actually only going to sketch the transformed graph. I'm not going to sketch the parent function. We're just going to go ahead and make this one a nice clean picture and just graph the transformed graph. And we're going to fill in the domain and the range after doing the graph so we can see some practice of what that will look like. So my first point is 1/4, -3. Then a point at 1, -1. Then a point at 4, 1. So we'll go ahead and connect those dots. Those points, rather. Making sure that I am approaching my vertical asymptote. And that's what that graph is going to look like. So let's fill out our domain and range based on that blue graph. So remember, the domain is how far left and right I can go. So I'm looking at how far to the left I can go. I can get really, really close to 0, but I can never touch it, so I'm going to use a parenthesis. And then I can go as far to the right as I want to go. So it's going to be going to infinity. And then my range is how far up and down I can go, which again, I can go as far down or as far up as I want, so it's from -infinity to infinity. Alright, I hope this has been useful for you guys as you continue practicing graphing transformations of logarithms.